Today, we will learn the highest common factor and the lowest common multiple. Let's first learn about the highest common factor, which is also known as HCF. To understand this, we need to find the factors of 20 and 24. The factors of 20 are 1, 2, 4, 5, 10, and 20. Similarly, can you list the factors of 24? Think about it. You are right. The factors of 24 are 1, 2, 3, 4, 6, 8, 12, and 24. Among the factors of 20 and 24, the factors 1, 2, and 4 are common. We call them common factors of 20 and 24. 4 is the highest number among the common factors of 20 and 24. Therefore, 4 is called the highest common factor. That means, for any two or more given numbers, the highest of their common factor is called highest common factor or HCF. It is also known as the greatest common divisor or GCD. Let's learn to find the HCF of the given numbers. Let's find the HCF of 20 and 24. First, perform the prime factorization of these two numbers. The prime factorization of 20 can be performed in the following way. The obtained factors as 20 is equal to 2 into 2 into 5. Similarly, perform the prime factorization of 24. This would be 24 is equal to 2 into 2 into 2 into 3. Now check for the common factors among the prime factors of these two numbers. As you can see, 2 is repeating twice among the prime factors of 20 and 24. There is no other common factor between the two. Therefore, the HCF of 20 and 24 is 2 into 2 is equal to 4. Let's now learn about lowest common multiple or LCM. To understand this, let's find the multiples of 6 and 8. The multiples of 6 are 6, 12, 18, 24, 30, 36, etc. Similarly, can you tell me the multiples of 8? Think about it. You are right. The multiples of 8 are 8, 16, 24, 32, 40, 48, etc. Among the multiples of 6 and 8, 24, 48, etc. are common. These numbers are called common multiples of 6 and 8. 24 is the lowest number among the common multiples of 6 and 8. Therefore, it is called the lowest common multiple. That means, for any two or more given numbers, the lowest of the common multiples is called the lowest common multiple or LCM. Let's learn how to find the LCM of the given numbers. Let's find the LCM of 6 and 8. First, we perform the prime factorization of these two numbers. The prime factorization of 6 can be performed in the following way. Therefore, we will write the obtained factors as 6 is equal to 2 into 3. Similarly, for 8, we get the factors 2 into 2 into 2. As we can see, the factor 2 is repeated thrice and the factor 3 occurs only once. The product of these prime factors will be the LCM of the given numbers. In order to find the LCM of 6 and 8, we will find the product of the prime factors occurring in maximum numbers. Therefore, the LCM of 6 and 8 is 2 into 2 into 2 into 3, which is equal to 24. There is another interesting method to find LCM. Let's understand this. Let's find the LCM of 6 and 8 by this method. First, we write 6 and 8 in a row with some space in between. Let's find the smallest prime number which will divide at least 1 among 6 and 8. In order to find such a number, we could take the help of divisibility rules. Both 6 and 8 are divisible by 2, so let's divide them by 2. By dividing 6 and 8 by 2, the results are written in the next row. Similarly, we find the smallest prime number which will divide at least 1 among 3 and 4. 2 is the smallest prime number. Since 3 is not divisible by 2, we will write it in the next row as it is. Dividing 4 by 2, the result is written in the next row. In a similar manner, we will divide 2 by 2 and write down the result in the next row, and we will write 3 in the next row as it is. Now, we divide 3 by 3. Now the method came to an end. To find the LCM of 6 and 8, we will multiply these numbers. Therefore, the LCM is 24. Today, we've learnt the highest common factor and the lowest common multiple. In the next video, we will understand it in a better way with some examples. Today, we will look at some examples of HCF and LCM. There are some fruits in this box. Can you find the minimum number of fruits that can be divided into 9, 12, and 15 equal parts? In the given example, we have to find the minimum number of fruits that can be divided into 9, 12, and 15 equal parts. This is possible only when the number of fruits is divisible by 9, 12, or 15. In order to find the minimum number of such fruits, we need to find the LCM of 9, 12, and 15. To do this, we will write these numbers as follows. Now we will find the smallest prime number which will divide at least one of them, that is 2. But 9 cannot be divided by 2, so we will write it in the next row as it is. We will divide 12 by 2 and write the result in the next row. 15 is not divisible by 2, so we write it again as such in the next row. By repeating the process, we will again divide the numbers by 2. We will write 9 and 15 in the next row as it is and divide 6 by 2 and write down the result 3 in the next row. The next smallest prime number to divide them is 3. Because the numbers 9, 3 and 15 is not divisible by 2, we will continue the process till we get 1, 1, 1 in the same row. In order to find the LCM of 9, 12 and 15, multiply these prime numbers to get 180. So, there should be a minimum of 180 fruits in the box. Next example. Harsh loves to solve puzzles. One day, he found a puzzle in a book. Puzzle was, I am a number which divides 324 and leaves 9 as a remainder and divides 470 and leaves 5 as a remainder. He got 15 as the solution. Can you tell whether he's correct or wrong? Let's understand the puzzle first. In the puzzle, the number divides 324 and leaves 9 as a remainder and divides 470 and leaves 5 as a remainder. If we subtract the remainder from dividend, the number obtained is completely divisible by the divisor. This means by subtracting 9 from 324, we get 315, and this is completely divisible by the required number. Similarly, by subtracting 5 from the number 470, the number obtained will be completely divisible by the required number. That means the required number will be the highest factor of both 315 and 465, which we call HCF. Let's find out the HCF of 315 and 465. First, perform the prime factorization of 315. We get 315 is equal to 3 into 3 into 5 into 7. Now perform the prime factorization of 465. We get 465 is equal to 3 into 5 into 31. Both 315 and 465 have 3 and 5 as factors. Hence, the HCF of 315 and 465 is 3 into 5, which is 15. Let's check our answer. If we divide 324 by 15, we get 21 with a remainder of 9, which is correct according to the riddle. Similarly, if we divide 470 by 15, we get 31 and a remainder of 5, which is again correct according to the riddle. Therefore, we can say that Harsh has found the correct answer to the riddle. Today, we saw some examples of the following concepts. In the next video, we will clear some misconceptions related to this. Today, we will see some common misconceptions and mistakes related to the following concepts. Misconception 1. Which of the following numbers is the HCF of 14 and 15? Due to misunderstanding, sometimes the method of LCM is used instead of HCF. The result will be 210, which is an incorrect answer. In order to find out HCF, prime factorization of 14 and 15 is done. Since there is no common factor among the factors of these two numbers, 0 is considered as HCF. This is a misunderstanding. The correct understanding is that 14 and 15 are co-prime numbers. That means among the factors of these two numbers, 1 is the only common factor. Therefore, HCF of 14 and 15 is 1. So, option 3 is the correct answer. Misconception 2. Which of the following numbers is the LCM of 90 and 84? In order to find the LCM of 90 and 84, many times their prime factors are written correctly. But by mistake, wrong factors are chosen. Since 2 and 3 are common factors for both numbers, those factors are excluded and all other factors are chosen for finding the product. By doing this, option 1 is chosen, which is incorrect. Similarly, sometimes ignoring the factors which occur only once, we choose the factors which occur more than once for finding the product. Hence, option 2 is incorrect. The correct way of choosing the factors is like this. Among the factors of 90 and 84, 2 has occurred a maximum of 2 times. That's why we write 2 into 2. Similarly, 3 has occurred a maximum of 2 times. So, we will multiply them with 2 into 2. Also, 5 and 7 have occurred only once. So, we will place them in the product. Hence, the LCM of 90 and 84 is 1260, which is option 3. Now, let's discuss some common mistakes related to HCF and LCM. Common mistake 1. While representing the factors obtained by prime factorization, sometimes addition or comma signs are used. It is very necessary to understand that while representing the prime factors, multiplication sign must be used. Common mistake 2. Sometimes students think that highest common factor and greatest common divisor, also called GCD, are two different concepts. So when asked to find the greatest common divisor, they get confused. It is very important to understand that the highest common factor and the greatest common divisor are both the same. We can say they only differ by name. Today, we saw some common misconceptions and mistakes related to the following concepts.